So my name is Christian Thalinger. I work for Twitter. I live in Hawaii, so the trip here was very long, but it's like a nice outside. It's sunny and a lot of snow. It's really cool. So this talk is a lot of demos, so a lot of stuff can go wrong. So far, the previous times I've given this talk, everything went fine, but today I'm not even using my own laptop, and I just downloaded the slides in the last second, and I don't have wired internet, so it's all a little flaky, and we'll see if it works. But I'm very confident that it will, and there's always a backup plan, right? I'll tell you a story about Hawaii if this shit doesn't work, and whatever. So I'll be talking about Graal and how to use it. So number one question, who has a Twitter account? Some potential candidates here. So Twitter has a small, I'll try to go through the slides very quickly because the talk will take at least an hour, and I'm not even sure if I can fit everything that I want to do. So I'll make it quick, I hope. Twitter has a VM team. We have about 4 engineers. We have 3 GC engineers and 1 compiler engineer, that's me. And so if you're going to tweet about this talk, every one of you who has a Twitter account, you're basically required to tweet about it. And then if you do, please add this hashtag so to let the other people in my team know that I was actually here. And the people who don't have an account, you should sign up right now. OK, so why my talks in general? Why the talks I'm giving are basically almost always compiler talks. And I'm very happy that so many people showed up, because usually it's only like 10 people that show up to my talks. And the number one question I have, besides do you have a Twitter account, is do you know what a JIT compiler is? OK, that's pretty good, so I don't really have to explain that too much. Who knows what Graal is? That's about the same. OK, good. So the main purpose of my talks is to get people to try Graal. OK? So we are using it. There are some reasons why I want you to try it. The number one, well, maybe it's not the number one reason, but for Twitter, the number one reason is we are using Graal because we save money by using it. There's a talk of mine that talks about this. Then what I want is to fix bugs in Graal, right? So the more people use it, the more code you throw at it, and the more bugs you'll find. Eventually makes the compiler more mature and better. It's good for us, for Twitter, right? That's why we're doing this. And also to improve it, right? If we throw more code at it, there are more patterns that show up, more optimization opportunities, and so on. So when I give my talks, then people come to me and ask me, so is it safe to use? Right? It's an experimental project. Can you really do it? Like, does your data center burn down or something? Our data centers are still running and up and well, so no, it does not burn it down. We're using Graal in production for now, I don't even know, maybe 8 months. Like everything you see and do on Twitter today runs through code compiled by Graal. It's like we run 100% in production on Graal. And then people ask me, how do I use it? Where do I get it? Right? All these questions. This talk today will answer all these questions. And then sometimes later they'll send me emails and say, oh yeah, I tried it. And then they're mostly complaining about that the benchmarks numbers are not as good as with C2. And then they usually say, well, and it really sucks. So that's because people don't understand that Graal is different. And so this talk will explain what's different and what you have to look out for. You can't just blindly take the benchmark you've been using for 20 years and just run it and compare just the most ridiculous numbers. It doesn't work that way. You have to know a little bit about it so that you can make an informed decision. So if you want to know more about saving money part, which I guess a lot of you do, because I like to save money. So there's lots of details in my other talk. It's called Twitter's Quest for a Holy Grail Runtime. It's a super punny title. I've given this talk at Joker in St. Petersburg, so there are a bunch of YouTube videos where you can watch it. It's pretty much, it looks like this. It's me giving the talk. That's how it looks like. So what is Graal? A lot of hands went up, so I don't have to go too much into detail. It's a Java virtual machine just-in-time compiler, right? That's what it is. When I say Graal, it's unfortunate that Oracle Labs basically rebranded their whole strategy. So there's something now called Graal VM. This is not what I'm talking about. Graal VM is the whole umbrella name for substrate VM truffle. Graal, the compiler, that's what I'm talking about. So historically, Graal was always the name for the compiler. When I say Graal, I mean the compiler. It's actively developed by Oracle Labs. These are the project pages, right? There's an official OpenJDK project. The source code is on GitHub. It uses JVM CI. We talked about this a little later. And it's written in Java. And this is the most important point of this talk, that Graal is written in Java, because that changes many things. If you write something in C++, it has very different properties to something that's written in Java. Okay? So remember that. Where do we get it? Good question. Okay. As always, the answer is it depends. And the problem with that is in JDK 9, we have something called ahead-of-time compilation. And ahead-of-time compilation is only supported experimentally on Linux x64. So there's this chap. Let's go to this chap real quick. Oops, that's not what I want. Let's go to this chap real quick. So ahead-of-time compilation, it's obviously closed and delivered because it was delivered in release 9. 9's out for a couple months now. So if we scroll all the way down here, we see the dependencies. It says, well, it depends on chap 243, the JVM CI, the Java Compiler Interface. And it uses Graal as the code-generating backend. So the AOT feature in 9 uses Graal to generate the native code. And then at the bottom, it says, this project will merge Graal core, which is Graal source code, into the JDK. That happened. And will deliver it in Linux x64 builds. And that's the problem. I mean, one of the reasons this talk I'll be doing, you will see, I'll fire up a Linux container in a cloud. I'm not doing the demos on my laptop. And that is mainly because we can only do it on Linux. So let me go back to here. Then there is a ticket that implemented support for Windows and Mac. So the container format, we use shared libraries, and that was only implemented for Linux in JDK 9. And so there's a bug. In 10, you can use it on Windows and Mac as well. That's why I said it depends where you get it, right? So you need a JDK with JVM CI, and then you need AOT, because AOT basically is the prerequisite of having Graal in it. And so what it means, OK, if you have a JDK greater equal than 9, that works on Linux. For Mac and Windows, you need something greater equal than 10. OK, good. So this is where we can get it. So we use a 9 version. This is the GA version, right? We download this one in a second. So I'm part of the Oracle Developer Champions program. And what this is Oracle gives me the opportunity to use their cloud infrastructure. They give me like a budget that I can just use. So and I'll be using Oracle's cloud for this demo. And so the way I do it, why is it doing this all the time? The way I do this is, let's close this stuff. So this is Oracle's cloud stuff. I said earlier a lot can go wrong during this talk, but the main reason I'm doing the talk the way I do it is when I see a talk and someone is giving demos, usually on their laptops or something, I wonder how long did it take them to prepare that everything will work, right? You spend hours and hours setting up the environment and shit like that. I don't do that. I fire up a completely from scratch Linux instance that has nothing in it. Not even Git. We'll have to yum install Git later because we'll need it. So this is how I do it. I shouldn't walk around too much because it's not. OK, here we go. So we fire up an instance in the cloud. And then we install everything there, everything we need. So what I'm doing today here on stage is basically what you have to do at home or on your Linux server to try this out. So everything I do today is basically what you have to redo, and then you can get the same thing. OK, so here we go. We're trying to create an instance here in Frankfurt, which is a little closer than the US. So we call it JBreak. Put it in this domain. And then we say, OK, we want Oracle Linux 7.4. I have to select, oh yeah, I select the Stens.io guy because it has the most cores. Then I have to select some networking stuff that I have no clue about. And then, did I select everything? Yeah, I think so. And then we say, oh yeah, we need SSH keys. So we grab my SSH key, paste it in here, said add, then launch, and I hope it works. Yes. OK, so now it's provisioning a cloud instance. This will take a while. In a second, we'll get a public IP address down here, hopefully. There you go. And now it's basically provisioning this instance. I can't log in right now. It's provisioning it, and then you'll see in a second it will turn green. It will say, oh yeah, it's up and running, and then it starts up. You've used the cloud before, right? You know how this works. And it starts up Linux and so on. So we're waiting for this. It will take a little bit. In the meantime, we're going back to the slides, and I'll tell you a little bit about me. So I worked on JVMs for a long time. I pretty much always worked on compilers because I don't know, it's interesting to me. And it seems people are interested here as well. I used to work back in the day, maybe I should put that on the slides too, before Sun open sourced the JDK, Java, OpenJDK. We were all working on GNU GlassPath, all that Wild West stuff, and we tried to beat the big guys. Sun. Yeah, but eventually I started to work for Sun, so then Oracle acquired us, and I was always part of the HotSpot compiler team. And so the three big things, I fixed tons of bugs in the beginning, but the main big three are what I've worked on was GSR 292. That was invoked dynamic. So John Rose and I, we were basically implementing all this stuff. So if you're using something like method handles or anything like this today, you can blame me. I wrote most of that stuff. Then I was responsible for getting JEP 243, the JVM Compiler Interface, into the JDK, into OpenJDK, because we needed that so that we can use Graal. So we got that into 9. And then we also worked on ahead of time compilation for 9, which, as I told you earlier, that's one of the reasons why you have Graal in it. And yeah, now I work for Twitter. I'm in the VM team there. So I'm a Oracle Developer Champion. I do other stuff as well. Like I organized the conference in Hawaii earlier this year. So if you guys want to come to Hawaii in January, it's really warm there. You can do that. I have 2046 Wine loops. Very important. People remember wine? I loved it. It's too bad it's dead. OK, let's see how far we are. Here we go. It's running. How about logging in? Not yet. Ah, damn it. Should have told you more about me. What else is there to tell? It's really warm in January in Hawaii. It's like 28 degrees or something, 30, depends. So if you're bored, I'll try to redo it next year again. Probably in January, because it's usually cold everywhere else, and then people want to come, and I get good speakers. We streamed the whole thing on Periscope, so if you want to watch it, look, there it is. OK, so I have to remember next time I give this talk, I have to talk about Hawaii. OK, here we are. So we're logged in, and we log in here too. We have 2 windows open because later we'll compare. So you guys, what C2 is? C2, the JIT compiler? OK, so there, HotSpot, you know what HotSpot is. Yeah, well, I don't know. So HotSpot has 2 JIT compilers today. One is called C1, or the client compiler, and one is called C2, or the server compiler. And the server compiler, C2, is the one that produces the peak performance code. When you do tiered compilation, there are a bunch of tiers, and tier 4 is C2. Okay? And what we do later is we turn on Graal, and then we replace the tier 4 compiler. So basically, we switch out C2 with Graal. That's what we're doing. OK, here we go. So demo. Here we go. So no, I was wrong. Let me go back. What we want, oh yeah, I had that link earlier. I should have clicked on it. So this guy, right? So we copy this one. And as I told you, I mean, there's no Java installed, right? These containers are completely empty, so we download all that stuff. Shouldn't take too long, hopefully. Yeah. It's because of Frankfurt. If I would have used the one in the US, it would download much faster. But in the meantime, because we need that too, we need to install Git. Right? We don't have that either. So let's do that. We have to wait for this. There will be some awkward pauses during this talk, but there's no other way around it. I could prepare it, but I don't want to do that. Because then it would be boring, right? For me, giving the same talk over and over again, and the slides will work anyway. And you're crossing your fingers that the projector will work, but this is much more exciting, right? So another 30 seconds. So we're going to download this one, and then I'll show you a few new flags. I know that the font is not too big, but you will see a lot of stuff. You can't remember all this now anyway, so you basically have to rewatch the video. There's not a lot in the slides either, so you kind of have to look at the video and then do what I did. Okay, here we go. 2 seconds, 1, and go. So we unzip this guy, which is called OpenJDK. There you go. Get this installing as well. It's called JDK something. And then we set Java home to this directory. And then we put it on a path because we're going to use it many times. Java home / bin. Yes. And we do the same over here as well. I don't know if you guys have given talks, but it's usually typing in front of a crowd of people is very exciting. Let's put it this way. So far, I'm doing good. Okay, so here we go. Java version. Oopsie. Perfect. So here we go. The next I'm going to do is I'm going to set up something here. It's called Java tool options. Options. Oh, the typing starts. Yeah. So. As I said, what we're going to do is we use parallel GC because we're going to look at some GC output later, and G1, it's better we use a kind of a predictable GC. So we do that, and to compare apples to apples, C2 is written in C++ and Graal is written in Java, and to compare apples and apples, we kind of set a pretty small heap, like 512 megs, and we also start with 512. So because with C2, you have for the application to wait basically to do that, to allocate all the memory and to map it in and stuff. And with Graal, it's different because it's using memory much earlier. Trust me. OK, good. So what else do we need? No, I think that's about it. So there is something called, what is it called? List modules, that's what it's called. List modules, here we go. These are all the modules that you have in JDK 9, and it's about 75 or something, I can't remember. And then we grab for something that's called AOT, and okay, this is the JDK.AOT module. And so there's another option called describe module. So we're describing this module, and what we're seeing is, okay, it requires a bunch of things, and it requires this jdk.internal.vm.ci. That's JVM CI. That's chap 243. That module contains the code for the interface. And it also depends on something called jdk.internal.vm.compiler. That's Graal. Okay? So if we have a JDK that has AOT, the EIT module, or, I mean, that's kind of a given, but you basically need these two. You need the VM CI and the VM compiler. If you have these two, you have something that can run Graal, okay? So let's go back here to this slide. So how do I use it? You get a JDK with JVM CI and AOT. We just verified this, so check. And then you just turn it on. That's really all you have to do. So how do I do that? Use it demo, here we go. Going back to the chaps. If we go to chap 243, which is the VM interface, and we scroll all the way down, you see here a bunch of flags that you have to use to turn it on. So ignore the one at the end. Basically, JVM CI is not tied to Graal. You could have any JIT compiler that uses JVM CI, but there's only one, so we don't really have to select it. So we need these. It's basically unlocking experimental VM option because it's an experimental feature. Okay, wait, let me copy this one here real quick. So we set this guy here. There we go. And we grab these, stick it in there. There you go. So now I can do a dash version and see, oh, it's picking all these up, right? And it's unlocking experimental VM option. It enables JVM CI, which only means it enables the ability to access the interface, right? It's not using the compiler. It's just enabling the interface. If you would run Truffle on top of that, then Truffle could access through JVM CI Graal, and it could schedule compilations. And then what you have to do to what I said earlier, replace C2 with Graal, the tier 4 compiler, you have to say use JVM CI compiler. Okay? So that's what it's doing here. But as we can see, nothing's really happening, right? I mean, there's no difference. It just runs. It doesn't tell us anything. So what's going on? Okay, let's look at this. So if we do, there's something called print flags final, and it prints all the flags that the VM has, like it's a long list. And there is one in there that's called, well, there are a couple in there, but there are JVM CI flags in there. Oh, sorry. I should do this. Always do a dash version, because otherwise you get all this crappy output. So here we go. So these are a bunch of JVM CI options. For example, enable, right, which we just use. It's true, so we turn it on. What I'm looking for is this one here. It's called JVM CI print properties. And this, here we go. It's a long list of properties, okay? It's called print properties because JVM CI is written in Java and Graal is written in Java. So we are passing in parameters as Java options, -D. That's how it works, okay? So there are only a few JVM CI options, these, and then the rest is all Graal, okay? So I'm looking for this one, the init timer guy. And we say D. And then because it's a Java property, we have to say true. And then we can say version, okay, like this. Okay, nothing's happening. So what the hell is going on? Why is JVM CI not initialized? Well, the reason is because it's not doing any compilations yet. So if we turn on print the typing. Print compilations, print compilation, not S. So these are the compilations that are happening when you do dash version. It's running a little bit of Java code. That's why it's compiling stuff. And you can see the third column here. This one is the tier level. Okay, as I said earlier, tier 4 would be C2 or Graal. We're not doing any tier 4 compilations here because the code's not hot enough. So JVM CI is lazily initialized because it takes quite a bit of time to do it. So that's why we do it lazily. And if no tier 4 compilation is scheduled, we're not initializing it. That's what's happening here. So what we need is something that does a little bit more. And we are downloading for that. We're downloading the Scala.capo benchmark because we're going to use it later as well to look at some performance numbers. So we need this. Which is rather big, so we're all crossing our fingers for download speed. Oh yeah, looks like that server is in Europe somewhere. Okay, so if we do this again, and we say Scala benchmark, and we do a -L, which just prints the benchmarks, right? You can see, oh, something's happening, right? So there's some JVM CI stuff going on. There's a class called HotSpot JVM CI runtime. We're initializing it, but it doesn't look like it's really finishing. And the reason for that is that the application we are running exits too early. Like the JVM CI initialization isn't done yet. Okay, so we have to run a little bit more. So we are doing a small run of Aurora. Okay, here we go. And the typing. So wait, let me do that again. Sorry. Oh, I also have to say this is like a Russian keyboard and stuff, right? So I mean, just for the typing. Okay, here we go. So now we can see JVM CI initialization actually finishes, right? Take 82 milliseconds, and then we do this select factory, which basically would select the compiler, but there's only one, so that's Graal. And then there's a HotSpot Graal runtime, which gets initialized, and that's the compiler. So we initialize the compiler, and then that finishes down here. There you go, here. And then we run the benchmark. Okay. So this, now you can see that it's actually doing stuff. I could, do a print compilation, and we would see a ton of compilations happening, but I think that would be a little too much. Okay, let's go back. So use it. You've just seen how to turn it on and how it runs. So I have to explain a little bit what bootstrapping is. So since Graal is just another Java application in your VM, and it's written in Java, it has to compile itself. We are not AOT compiling it. We don't have native code for it. It's just Java bytecode, and we have to, like everything else, interpret it first, and then we compile it. And that's called bootstrapping. There are different ways of doing bootstrapping. Right. I should have said that, right? It loads, since it's written in Java, it loads Java classes, and it has Java methods, right, which at some point need to be compiled. So let me show you, there are different ways of bootstrapping. Let me show you this in a demo. There's something called, yeah, let me do it like this. There's something called bootstrap JVM CI. And there's a typo I noticed. And that's an explicit bootstrap. So we tell the VM, or we tell Graal, bootstrap yourself. Okay? So it's doing that. As you can see, every dot is, I think, 100 compilations or something like this, so it's bootstrapping itself. So what happens is we schedule all the methods of Java lang object, which they're very simple methods, right? There's not a lot happening in these objects, in these methods. And we schedule these, and when Graal starts compiling them, it runs more of itself, which is also Java code, and that code gets hot. And when that code gets hot, it needs to be compiled by Graal, and more code gets hot. And so that's why it ends up compiling like 2,300 methods of itself. Okay? This takes 9 seconds on this machine. It grabs all the cores that it can get. I think it's 4 in this case. And it's doing it as quickly as it can, 9 seconds. That's a long time, I understand. But later you'll see it doesn't matter. Okay? So you can do this explicit bootstrap, but if we go back to this example, I should have set that up, to this example. When we run this small benchmark, how long does it take? 5. Certainly less than 9. So how did this work, right? If we do a print compilation here, and we grab for org.graalvm, you'll see a bunch of compilations happening, a lot, and they're all tier 1. So the default setup is, if you're doing an implicit bootstrap, not with the flag I just showed you, when you're doing an implicit bootstrap, Graal itself will only be compiled by C1. And the reason for that is C1 has much higher throughput. It's a much faster compiler. It's not optimizing as much, but you get code quicker. So, and that's why we only saw like a 5-second runtime. Maybe I should, wait, let me show you this, just to compare. So copy this guy, run it over here with C2, and you'll see it's like a 4 point something, if I remember correctly. It's a little, benchmark's a little flaky, yeah, 4.3, okay? So basically, what we wasted was about 700 milliseconds just to turn on Graal, and these are all these compilations, okay? There is, you see these tier 1 only compilations. There is, when we look at, what is it called? Print JVM CI properties, that's what it's called? No. Why did they name it like this? Because it's JVM CI print properties, doesn't make any sense. There's a flag in here that's called C1 only. Here, this one. This one basically tells Graal, oh, compile yourself only with C1. It doesn't really tell Graal. It actually tells the compile broker, but ignore that for now. You can turn that off. And if you turn it off, then Graal will compile it with itself with itself. One thing I want to show you as well, how much time do I have? Yeah, all right.
25.
Good. I take as long as I can. So if we turn off tiered compilation and we do an explicit bootstrap, you will see this will take a very long time. And what's going on here is when you turn off tiered, you only have one compiler in the system, and that compiler is Graal. And so all the compilations that are happening are Graal. So you start up interpreting a lot, and then you only compile with Graal. You end up with better code for Graal itself, which later in the game would mean your compilations will be faster, but it's a trade-off. Because usually all your compilations for your application happen in the very first few minutes, let's put it this way, right? Later, you don't really compile a lot anymore. So if you can do this, it might be helpful for your particular situation. We don't do that. We don't do explicit bootstraps. We at Twitter, we just let it go. And I'll show you later how that looks like. So you can see if you turn tiered off, we compile way more methods, like 4,600, which is twice as much, and it takes 27 seconds to do this. But don't be scared. I'm just showing you the facts, but this does not matter. OK, back to the slides. So we learned bootstrapping compiles a lot of methods, yes, of course, but it really doesn't matter that much. You can do it either upfront or during the runtime. That's what basically happened when I ran the small benchmark, right? It was just compiling Graal in the background you didn't really notice. And by default, it compiles Graal with C1 only. It's like this. I think this is a bug. The explicit bootstrap, when you turn the flag on, it compiles with Graal as well, which doesn't make any sense, because if the flag is true, C1 only true, why does it do it? I think it's a bug. I'll talk to the labs folks about this. So Java heap usage, very important. Graal is, exactly, it's written in Java. So number one difference between C2 and Graal. It will use Java heap memory for compilations, right? A compiler needs memory for compiler graphs and all that stuff. That can be a lot. You know, if you compile big methods and you do a lot of inlining and you do loop unrolling and all these stuff, it allocates nodes and things. A compilation can take, I mean, these are worst case scenarios and outliers, right? Can take up to hundreds of megabytes of memory, even 500 sometimes. And then, you know, when you run something and you have Graal on, you have to remember that. It will be using Java heap memory. And and also Graal methods itself, possibly. You know, remember that flag. It depends on the setting of that one. So let me do a demo about this. And we use this guy. Yeah, we use that guy. That's a good one. And we turn on xlog gc. And we're using parallel, and we have this small heap, right? And so this benchmark Aurora, it's a compute-intense benchmark. It doesn't do a lot of allocations, as you can see. It's like these two collections that are happening are forced collections by the capo benchmark hardness. Okay, because they want to clean up before they start running the benchmark. But during the benchmark, we're not collecting. And remember, we only have 512 megs. If I run the same thing over here with Graal, it looks like this. OK, so there's stuff going on, right? Obviously. So there are some collections happening. But you see the runtime, yeah, it's a little slower. But this is the memory that was being allocated to compile your application methods. In the case of C2, you would use that memory as well, but from the malloc heap. You wouldn't see it, right? So that's one big difference, where it's being allocated. In a cloud world like it is today with all this container stuff, you get your container with a certain amount of memory. If the memory you use is a native or on the Java heap, doesn't really matter. The only problem is, and we do that too at Twitter, like everyone's tuning their heap size to just the bare minimum, right? You're running your stuff and you know how much it uses, and then you give it exactly that amount plus 1 meg more just because. But if suddenly a compilation comes in that uses 200 megs, well, then you're screwed, right? So this is something to remember. But it's not that bad, because as I said, most compilations, I don't know if you guys have used something like Flight Recorder or something and look when compilations are actually happening during the runtime of your application, it's in the very beginning. Most compilations happen in the first 30 seconds to a minute. And at that time, your application is not even fully up to accept requests and use all of your 8 gig of heap or how much you have. So in the beginning, it doesn't matter. If the compiler uses 400 megs or whatever, who cares, right? Once you're up, then it might be different. But at Twitter, we've not had a single problem with that. So, OK. So what have we learned? As I said, it uses Java heap memory. There's no heap isolation yet. I'm not talking too much about this, but this is something that we want in the future. Because the worst case that can happen is you run your application, Graal compiles something, it uses too much memory, you get an out-of-memory error. But that out-of-memory error might not end up on the compiler thread. It might end up in your application. And then it brings your application down. So this is the worst case that can happen. So what we want is heap isolation, that Graal heap allocations happen in a different arena, or like if we would use T1, it could be a different region that's only for compilations and so on. There are different things that can be done. But as of today, this does not exist, so you have to remember that. Most memory usage during startup, that's what I said. Most memory usage by Graal during startup, right? Usually when application's not fully up yet, memory is used anyway, either malloc or Java heap. OK. So running bleeding edge. So the version, I can't remember, when was JDK 9 released? 3, what, September? No, I can't remember. So the version in JDK 9 of Graal is kind of outdated. It's about, I almost want to say it's 2 years old. Yeah, I think so. Or 1, at least 1. I can't remember. So, but you can get Graal from GitHub. So I have to do something now, because I want to do this production demo later. And did I download Git yet? Yes, I did. OK. I want to do this production demo later. And I'm going to use something called Finatra. And Finatra is, I never can remember what it is. But it's some Twitter framework that we're using. Here we go. Finatra is a lightweight framework for building fast and blah, blah, blah. Twitter server finagle. Who the fuck knows what that is? I don't really care. It's mostly written in Scala. It's some stuff that we use. When Twitter releases a lot of the stuff open source, when it's the lower layer of our logic, we can't release the IP on top, right? But the frameworks we do. And this one we use, and it has. Let me quickly copy this guy. So we are cloning this one. And it has examples in it. And it has one that's called Twitter clone. OK, so it's, it serves you a tweet. It's pretty much what we do at a very small scale. So we are going to do this. We're going to run this later. But it takes about 4 minutes to build, thanks to Scala, C in that case. So we have to build it now while I'm doing this other demo. So bear with me a little bit here. And I'm trying to find my notes. OK, here we go. Since we're using Java 9, and it's all very bleeding edge, right? So Finatra. You can't really build it with 9 out of the box. So I actually had to, when I was preparing this talk, I had to fix Finatra to make it work. So it's like, I think it's like this, 20 minutes. OK, cool. That's good. So we have to add this. And then there's one more thing we have to do. Yes, this guy. OK, so this is what I was talking about earlier. Okay, if I would have set up this days and days before and spent hours to figure out why the fuck do I need to set the CA certs differently, I could, but I don't have to. So I have to pass this in, and then I can build it. Otherwise, it doesn't build because it can't access HTTPS URLs and whatnot. So we're doing this. Doesn't work because we have to unset this guy. It's a little unhappy with settings. Okay, here we go. Let me see. Let me see if it really starts building. And so we're assembling this Twitter clone example. Okay. Yeah, I think it runs. This will take a while. So, and in the meantime, we're going this. Doing the Graal demo. Okay. So back to the browser, GitHub. For Graal, we need Graal, obviously. So we go search for Graal. Here we go. It's the Oracle/Graal. It kind of had many different places where it was living because Oracle Labs they don't know what to do, and they haven't made up their mind, so they're moving it around all the time. So it's on the Oracle Graal these days. So you grab that. Okay. To go here, clone it. It grew over time because, as I said, it's now this umbrella thing. It has now, they just released Substrate VM, so it has all the Substrate VM source code in it, and it has Truffle in it, and the compiler, you name it, so that it grew. That's why it takes a while to clone. And then we need something else, which is called MX. And MX, it's an old, they use it as it's a script, and a very big one, by the way. And it's coming from the Maxime project, if someone remembers that one. It was an Oracle Labs project that was building a complete JVM in Java, like JVM, if you remember that. So it comes from there. So you need that to build Graal. But once you have it, it's very easy to use. OK, so MX, what we want is path. We want to put it on the path and not screw it up. OK, here we go, Graal. And as you can see, I told you it has Substrate VM in it, it has Truffle in it, and it has the compiler in it, right? That's what we want. So we go in here. There's a bunch of things in here, and then you can run MX in here. Yes. What we want to do, I unset these. We could probably have it on, but I turn it off, and I have to, things can go wrong. I'm not exactly sure how it will turn out if I compile Graal with Graal itself. So I just disable this for now, and it's just for compiling. So the only thing you have to do, right? You saw I just cloned it. I didn't do anything. The only thing you have to do, I have set Java home. You remember that. I've set Java home. That's important. And then you say MX build. That's it. And then it should start building. At the same time, I'm building a lot of Scala code on the side, so it's racing with that build as well. So it's building Graal. You see, it's compiling all these projects and packages. So Graal's very modular, not in the JDK9 module way, but they basically re-implemented Java 9 modules before they were out through MX in a way. But the good thing about it is MX checks for dependencies between projects, so that no circular dependencies exist, and that compiler, that platform dependent code, no, the other way around, that platform independent code does not depend on platform dependent code. It makes sure of all these things. Okay, so it's building this. It fails. Fine, doesn't matter. The reason why I don't care about this is because I would have to install GCC, but since it's a completely from scratch cloud instance, doesn't have GCC, and this is only for Truffle, and we don't do Truffle, so we don't care about this. It should have built, I really hope it did. MX build, that's where all the stuff is, and there's a dist in here, and no, I don't think it finished it. Let me try this again. It's kind of, sometimes it's the build process is racing, and then it doesn't finish. Yeah, no, it's not done yet. If I had GCC, it would be fine. But we just rerun this. We're looking for archiving Graal. That's what we're looking for. And then, once it's doing this, archiving Graal compiler, that's already pretty good. And I think that's what we needed. Let this finish real quick. And what it produces then is a modular char file. You've heard of this now. 9's out for long enough. You should know what a modular char file is. Awkward pause. We have to wait a little, sorry. Yeah. This is what we want. OK. Right. So now we should have in here dist. No, is it not dist? Oh, no, here, modules. That's what we want. That's the modular jar file. Okay, and this modular jar file, we now use that one and put it on. MX does this for us. Luckily, you can say mxvm -version. It won't show us anything, right? Because it's just replacing Graal with what we just built. But we can do a -v, and then we see what it's actually doing. And this is the command line. And we are upgrading the module path with this modular jar file we just built. And we can. How much time do I have?
20 minutes.
OK. So we look at this. Class, is it like that? I always forget. You guys probably know better than I do. And let's say, no, OK, wait. No, we do this. We say mxvm, and then we say xlog class load, if I remember correctly, and then we pick up the Scala, the couple benchmark again, and say Aurora, and it should be doing something right. Is it doing what I want, or is it not? Oh yes, it's doing what I want, but we've unset this, so we weren't using Graal. So let's turn this on. And now if we grab for Graal VM, for example. Right, here we go. So I'm canceling this. It doesn't really matter what it's doing. But as you can see, all the Graal VM classes are being loaded from our modular jar file. So we're really picking up what we just built, and we're running the benchmark with it. It's just for fun. Hang on, here we go. Let's just run this benchmark. The one we ran before, it took like, what, 5.3 seconds or something like this. So let's just make, yeah, that's about the same. So they didn't fix anything or made it better. But there's constantly, progress with Graal. OK. So now you can go to GitHub and just grab your Graal source code and build it, and then run on the latest JIT. Make your own changes, do whatever you want, upstream stuff, fix bugs. That would be nice, fix bugs. So now coming to what we built in this other terminal, right? I would like to show you the bootstrapping, that it's not really an issue. Okay, so this the bootstrapping usually disappears in the startup noise. With that one little benchmark that we ran, we saw it was about a second maybe, or something between half a second and a second slower than a run with C2. But that's really noise in a 5-second run. None of your applications start up in 5 seconds. I truly believe that. And so all the free CPUs cores we have at the very beginning, when your application starts up, it will be single-threaded for a while, and then you fire up all the things you need. There are a bunch of free CPU cores laying around that you're not using right now. And the compiler will just grab them. It will grab them and then compile the stuff you need, and then you're running on it, right? So let's do this production demo. And let me, yeah, that's, I don't know how, you guys know SBT? Every time I use SBT, it fucks with my terminal, and then you can't see anything. OK, here we go. Finatra, yes, we need these again. And I need to go back here. No, not here. I need to go back here. And then figure out how to run it. So we say Java char. No, not char yet. We need to turn this on. Otherwise, it's not printing anything to the console. We don't even know what's going on. Oh, and then we need something, because it's 9, and we have added that to the build as well. Add modules. It's the Java SEEE module. That's not added by default, because at some point it will be deprecated. But today, we still need it. So we pick that one up. And then there's a jar file in here, and it's called Twitter clone. So that's our application basically. And then the last thing we need is these. This is really not important, but without these, this application doesn't work. Okay, so let's see if it works. I hope it does. So it's starting some things up. It warms itself up, right? It does a bunch of tweet requests. It says get tweet 1 to 3, and it posts tweets and gets tweets, and it says startup complete. So it works. Okay. Let's do that again for fun. And also, so here we go. Shut that down. And let's do the same thing with Graal. Have I turned it on yet? Yes, I did. OK. So we do the same thing with Graal. We do an implicit bootstrap. We'll let just Graal and the compile broker do its job. It will compile stuff. OK, it's ready. OK, so let's see. Here, it's like, what's that? 25.6 and 30.8, so that, what, 5 seconds? It's a small example, I understand, but it's really the logic we are using, just on a bigger scale, okay? So this takes about 5 seconds to start up with C2. And over here with Graal, it's 40.6, 46.8. Okay. So, but pretty much everything's up, because it has warmed up itself, all the methods are already hot, maybe there will be some compilations later. Of course, in real Twitter would be way more, but it's just 1 second. No one cares. So the 9 seconds we saw earlier that a bootstrap, an explicit bootstrap would take, it's not 9 seconds. It's really not. And if this one would take, let's say, 30 seconds to start up, it would only be 1 or 2 seconds slower. So the gain we get by running Graal and saving later during runtime is much, much greater than the little bit of startup time that you're losing in the beginning. All right. Let me show you something else, because I just remembered. So what we're doing is we're running through time. There's a neat little switch. It's called CI time. It's basically it's called CI for Compiler Interface. It will show you the time that it's spending in the different compilers. And the time in the beginning, I do to show you the CPU utilization. So let's do that over here too. CI time. Here we go. OK, let's scroll back. And then we see, OK, there are a bunch of C1 compilations going on. It took like 1.5 seconds. It was 3,500 methods. And we did like 500 C2 compilations, OK? And for that, we used about 200% CPU. So it was some application logic, right? I'm not exactly sure if that thing is single-threaded or not. But it's like overall, we use 200 with the compilation threads, possibly GCs. I don't know if they're GCs or not, to be honest. And over here, that was Graal. We see, let me scroll back up here for the comparison. Here we go. 9,000, OK? That's more than twice as with C2. So these 9,000 is Graal itself plus core library methods that are getting hot because you're using Graal. And you see it takes about twice as much time to compile this with C2. It's really not a lot. And then this is JVM CI, right? That's Graal. And we compile almost twice as much methods with Graal here. And that's also the core library stuff. Because as you remember, we have this flag turned on that says compile Graal with C1 only. So these can't be Graal compilations. It's just other stuff besides your application or the Twitter clone example here that's getting hot enough that it's being compiled with tier 4. And it's very likely core library methods. Takes much longer. Doesn't really matter. Yeah, this is not right. I have to run this again. I let it run for too long. I have to Control-C it right when it's up. Then we see how much. Here we go. 290. So basically, we use one core more to run with Graal, and that's what I was telling you about. Like we have, I think, 4 here, and you're starting up with C2, and you're only using 2, right? And the other 2, or one additional more in the Graal case, is just being used to do all these additional compilations. And the overall startup time was just about a second slower. All right, so back to the slides. Production demo. Oh, Scala demo. Yeah, I think I have time for this. Do you have time for this? It takes about 5 minutes.
5 minutes.
OK, let's do the Scala demo. Because then you'll see why we're actually saving money. So we increased the code, the heap size a little bit, because this benchmark just uses way more memory, and otherwise we would be 2G. So we do that. We say scala.capo. Scala, here we go. And we use default, and the benchmark is called factory. So we could, it takes a while to run. I think it takes like 25 seconds or so. If I go here and back, and then benchmarks, and then you can see factory here. I'm not exactly sure what it's doing. It's some probabilistic modeling for latent whatever. Okay, but this benchmark will show you, yeah, it takes about 27 seconds. Here we go. This benchmark will show you where Twitter is getting all its wins. Okay, let's run this with Graal. Ah, yes, thank you so much, because I would have been confused. Heap size, 2G. Okay, what do you think? How long? Not long. But longer than I wanted to. Come on. It's crazy how long 10 seconds can be when you're waiting for it. 20. Actually, that should be less. But so the main thing, what's happening here is Scala. I don't know how many people of you use Scala, but when you use it, the code that's being compiled for Scala on the bytecode level, it has it's, you know, yes, exactly. It's not as clean as Java is. It has a very polymorphic nature to it, and the way Graal does inlining just works much, much better with Scala code. So one thing we want to do here is we want to look at GCs. And we do, it takes a little long. Let's do 3 rounds. I hope we have enough time for this. I'll just, you know, you guys are not leaving anyway, so, and they're not kicking me out. So there's a bunch of stuff going on. So this benchmark allocates a lot of memory to do things. And so we wait for this. So that the first round is always a little more noisy. It kind of warms stuff up, and then the second and third round will be much better. And then we can look at stuff and compare it. Okay, just have to bear with me a little bit here. And then we look at this. All right. A little bit longer. So the first run was 27 seconds. I think that one takes about the same, if I remember correctly. 25, yeah, that's what it should be. Okay. And then we start at GC 98 here. And that's kind of what we want to look at. Good. 20 more seconds. I'm sorry about this. I hope it's not very boring. But you know, I could put this on slides as well, right? And we would browse through it, and it would be amazing. But this is more exciting. Okay, here we go. 25. Good. Let's run this over here with Graal. It fits exactly on one screen. It's amazing. There you can. These are all the GCs that are happening for this one run. And we start at 98. We end at 139. So that's about 40 GCs, roughly. Okay, and we're, as you can see, we're collecting about the same amount every time, almost 700 megs. And so on the right, as you can already see, way less GCs happening, right? Even in the first round already. So let's wait for the second and third round. And that's where a lot of the savings are coming from. So number one, what's happening is escape analysis implement. People know what escape analysis is? Yeah, I need to do a talk about this stuff because people don't know. So escape analysis basically gets rid of temporary allocations that you don't need. Perfect example would be a local variable that's an object, an integer. Best example. A local variable that's a capital I integer object. If you only use it in the local method, you can escape analyze it. You can scalarize it and take the integers that are actually stored in the field and put it in a register. That's what escape analysis basically is. And Graal is very good at doing this. And the more you can inline, the better escape analysis can work. And that's exactly what's going on here. So it can escape analysis. These are what, where are we? 55, 74. That's half the amount of GCs. And we are collecting the same amount, roughly. It's using a little bit more because Graal has some state. Right? It's a Java object. It has some state. That's why we use a little bit more of HEAP here. But it's still half. I mean, it's ridiculous. I mean, this is the best case example that I know of, right? At Twitter, we don't save that much. If you watch my other talk, I don't know, it's a few percent. It's definitely not 50. But this is where the gains are coming from. So number one, you save by not doing the GCs in the first place. But it's also because it can escape analyze these objects, it doesn't have to allocate them, which means the code will be tighter. Your generated code will be better. And this is where the other wins are coming from. So how much time?
0.
Perfect. So these are the two areas where you're winning. You're not doing the GC, and you're also producing better code at the same time. So let me go back to my slides. Summary. That's really all you need. Yeah, exactly. That's what you need. This is what you need, really. As you've seen, I mean, I did everything from scratch. I didn't do anything special. You just download JDK9 and you use these flags and turn it on, and then you'll see if it's better for you or not. It can be. It can also be with regular Java code that you see advantages. It will not be as big as the one you will see with Scala code, but it can. So give it a try. Save some money if that's good for you. It would be great. I would be happy. I would be more happy if you would find bugs. File them upstream on GitHub. You don't have to fix them yourself. If you would, that would be even better. But if you find them, that's already helping out the whole project and us at Twitter as well, because then we don't run into them. If you're a compiler engineer, work on it, make it better, whatever. Give it a shot. Cool. Don't forget to tweet about it. Thank you very much.